So now we're going to talk about Cramer's rule and 3 by 3 matrices, and these get just a little bit trickier because it's harder to find a 3 by 3 matrix. So we're going to start by giving the definition, and so our D again is just the coefficient matrix, A, B, C, D, E, F, G, H, I, and suppose we have a J, K, L as our B matrix. Well, DX is going to be replacing J, K, and L, B, C, E, F, H, I. Our dy comes from replacing the middle, so D, G, C, F, I. And dz comes from replacing the end, so AB, DE, GH, and then JKL replaces the last column. And x is simply dx over d, y is dy over d, and z is dz over d. So, let's suppose that we have the system 3x plus 2y plus z equals 4, 4x plus 3y plus z equals 5, and 5x plus y plus z equals 9. Well, first we're going to set D as 3, 2, 1, 4, 3, 1, 5, 1, 1, and we're going to do this. And so I'm going to pick my ugliest row and column, which is the first column, and this will go plus, minus, plus. So D is equal to a positive 3 times 3, 1, 1, 1. Then we're going to subtract 4, oops, that should be blue, 4 times 2, 1, 1, 1. And then we're going to add 5, oops, that should be blue, times the matrix 2, 1, 3, 1. Remember, we're always ignoring this column, but we're going to ignore this row first, then this row, then this row. Well, this is 3 minus 2, 1. This is 2 minus 1, and this is 2 minus 3. So that gives me 3 times 2 minus 4 times 1 plus 5 times minus 1, which is 6 minus 4 minus 5, which is minus 3. So my determinant of the whole thing is minus 3. Well, now we need to do dz, and dz comes replacing the first column with 4, 5, 9, or sorry, dx. So dx is 4, 5, 9, 2, 3, 1, 1, 1, 1. And again, this is going to be my ugly piece, and it goes positive, negative, positive. So we're going to get 4, positive 4, times 3, 1, 1, 1, and we already know 3, 1, 1, 1. We've already done him. That's 3 minus 1, or 2. So we can speed up by reusing the pieces that we have, if there are any. Minus 5 times 2, 1, 1, 1, which we already know is 2 minus 1, or 1, plus 9 times 2, 1, 3, 1, which we already know is 2 minus 3, or minus 1. So this becomes 4 times 2 minus 5 times 1 plus 9 times minus 1 is 8 minus 5 minus 9, which is minus 6. So D was minus 3, dx is minus 6. We'll move on to dy, which, if you remember, started as 3, 4, 5. We're going to replace this with 4, 5, 9, and 1, 1, 1. This is still my ugliest piece, but now the signs change. It goes plus, minus, plus, minus. So this is going to be equal to a minus 4 times 4, 1, 5, 1 plus 5 times 3, 1, 5, 1 minus 9 times 3, 1, 4, 1. Well, in this case, we're going to get minus 4 times 4 minus 5 plus 5 times 3 minus 5 minus 9 times 3 minus 4. Well, that's a minus 1, a minus 2, and a minus 1. So minus 4 times minus 1 is 4. 5 times minus 2 is minus 10, and minus 9 times minus 1 is plus 9, which is 3. So now we know d is minus 3, dx is minus 6, and dy is 3. And I'm rewriting these just because we're going to keep moving. Oops, we're going to keep moving, and I still want to know what they are. Well, now we need dz, which has the first row the same, the second row the same, so 2, 3, 1, but it replaces the last row with 4, 5, 9, last column, and I'm still going to keep that column, but now it goes plus, minus, plus, minus, plus. So this is going to be equal to a positive 4 times the matrix 4, 3, 5, 1 minus 5 times 3, 2, 5, 1 plus 9, well, that should be blue, times 3, 2, 4, 3. So this becomes 4 minus 15 times 4 minus 5 times 3 minus 10 plus 9 times 9 minus 8. So remember, we multiply that and subtract the down one, the up one from the down one. Well, this is 4 times minus 11 minus 5 times minus 7 plus 9 times 1. So that's minus 44 plus 35 plus 9. Well, minus 44, 35 plus 9 is 44, so this is minus 44 plus 44, so this turns into 0. So d is minus 3, dx is minus 6, dy is positive 3, and dz was 0. So now we come back down, and all we have to say is that x is dx over d, or minus 6 over minus 3, which is positive 2. Y is dy over d, which is minus 3 divided by 3, which is minus 1. And z is dz over d, which is 0 over minus 3. Got those upside down, which is 0. So my solution is the point 2, minus 1, 0.